Hello students, today we are going to see next lecture based on additive property of binomial distribution. We have to see examples and problems based on additive property of binomial distribution for TY BCom students. Subject Business Statistics second paper. See additive property of binomial distribution. Let X follows binomial distribution with parameters n1, p and Y follows binomial distribution with parameters n2, p and X and Y are independent, then Z is equal to X plus Y will follow binomial distribution with parameter n1 plus n2, p. See the example based on this property. Let X and Y be two independent binomial variables with parameters n1 is equal to 3 and p is equal to 2 by 3 and n2 is equal to 4 and p is equal to 2 by 3 respectively. Find first part of the problem, probability x plus y is equal to 5. Second part of the problem, probability x plus y less than 5. So x follows binomial with parameters n1 is equal to 3 and p is equal to 2 by 3. Y follows binomial with parameters n2 is equal to 4 and p is equal to 2 by 3. Then z is equal to x plus y will follow binomial distribution n1 plus n2, that is nothing but 3 plus 4 comma 2 by 3. So z will follow binomial distribution with parameter 7 and 2 by 3. We have to find probability z is equal to 5. So which can be written as 7c5, 2 by 3 raised to 5 and 1 by 3 raised to 7 minus 5. 7c5 the expansion is 21. 2 by 3 that is 0.67 raised to 5 can be considered as 0.131687 into 0.3333 raised to 2 can be considered as 0.11111. So the value becomes 0.307269. Now second part we want probability x plus y less than 5. So we can take the complementary event as 1 minus probability x plus y greater than or equal to 5. So we will have to find 1 minus probability x plus y is equal to 5, which already we have calculated. Then probability x plus y is equal to 6 and probability x plus y is equal to 7. So this part we have with us. So we will find probability x plus y is equal to 6 can be written as 7c6 0.6667 raised to 6 into 0.3333 raised to 1. So the answer for this is 0.204887793. Then probability x plus y is equal to 7 is considered as 7c7, 2 by 3 raised to 7 and 1 by 3 raised to 0. So 7c7 the value is 1. 0.3333 raised to 0 the value is 1. So 0.66667 raised to 7. The answer is 0.0584867. So probability x plus y less than 5 is equal to 1 minus probability x plus y greater than or equal to 5, which is equal to 1 minus probability x plus y is equal to 5 plus probability x plus y is equal to 6 plus probability x plus y is equal to 7. So which can be considered as 1 minus 0.3072 plus 0.2048887 plus 0.0584867, which is equal to 1 minus 0.5705737. So the final answer comes out to be 0.570 4294263. Next example, which is also based on the additive property. Let x and y be two independent variables having binomial distribution with parameters 5, 1 by 2 and 8, 1 by 2 respectively. Find first part of the problem, probability x plus y is equal to 5. Second part of the problem, probability x plus y less than or equal to 1. Third part of the problem, probability x plus y upon 2 greater than or equal to 1. Fourth part of the problem, probability 3 into bracket x plus y less than or equal to 6. Now we will apply the additive property of binomial distribution. We have given that x follows binomial distribution with 5, 1 by 2 and y is following binomial distribution with parameters 8 and 1 by 2. By additive property of binomial distribution, x plus y will follow binomial distribution with parameter 13, 5 plus 8, 1 by 2. So therefore x plus y follows binomial distribution with parameter 13 and 0.5. So probability x plus y is equal to 5 can be considered as 13c5, 0.5 raised to 5, 0.5 raised to 13 minus 5. So which is equal to 1287 into 0.03125 into 0.00390,625. So if you take the product, the answer is 0.157104. Second part, we want probability x plus y less than or equal to 1 can be written as probability x plus y is equal to 0 plus probability x plus y is equal to 1. So probability x plus y is equal to 0 is calculated as 13c0, 0.5 raised to 0 and 0.5 raised to 13. So 13c0 the answer is 1, 0.5 raised to 0 the answer is 1. So 0.5 raised to 13 the answer is 0.0001220. Then probability x plus y is equal to 1 is equal to 13c1, 0.5 raised to 1, 0.5 raised to 12. So which is nothing but 13 into 0.5 into 0.000244140, which is equal to 0.00158691. So probability x plus y less than or equal to 1 can be calculated as 0.0001220 plus 0.00158691. So the total is 0.00177089. Next part of the problem. Next part of the problem, probability x plus y upon 2 greater than or equal to 1. These two will get cross multiplied with 1 and we can write this inequality as probability x plus y greater than or equal to 2. So which can be considered as 1 minus probability x plus y less than 2. So 1 minus probability x plus x is equal to 0 plus probability x is equal to 1, which already we have calculated. So we will replace the values. So the answer becomes 1 minus 0.00158691 plus 0.0001220, which is equal to 1 minus 0.0017089. So the answer, final answer is 0.99829. Next part of the problem, probability 3 into bracket x plus y less than or equal to 6 can be considered as probability x plus y less than or equal to 6 upon 3. So which is nothing but probability x plus y less than or equal to 2, which is nothing but probability x plus y is equal to 0 plus probability x plus y is equal to 1 plus probability x plus y is equal to 2. Now we already have calculated probability x plus y is equal to 0 and probability x plus y is equal to 1. So we have to calculate probability x plus y is equal to 2, which can be written as 13C2 0.5 raised to 2 and 0.5 raised to 13 minus 2. 13C2 the value is 78, 0.5 raised to 2 the value is 0.25 and 0.5 raised to 11 the value is 0.00048828. If you take the product, the answer becomes 0.00952148. So therefore probability x plus y less than or equal to 2 can be considered as 0.0001220 plus 0.00158691 plus 0.00952148. So the total becomes 0.011230. Next example based on additive property. Let x and y be two independent binomial variables with parameters n1 is equal to 5 and p is equal to 0.4 and n2 is equal to 6 and p is equal to 0.4. We have to find first part of the problem, probability x plus y is equal to 4. Second part of the problem, probability x plus y less than or equal to 8. So x follows binomial with n1 is equal to 5 and p is 0.4. Y follows binomial with parameters n2 is equal to 6 and p is equal to 0.4. So we'll apply the additive property. Therefore x plus y will follow binomial distribution with n is equal to 5 plus 6 and p is equal to 0.4. So therefore x plus y follows binomial distribution with n is equal to 11 and p is equal to 0.4. So in the first part of the problem we have to find probability x plus y is equal to 4, which can be written as 11C4 0.4 raised to 4 0.6 raised to 11 minus 4. So 11C4 the expansion is 330, 0.4 raised to 4 the value is 0.0256 and 0.6 raised to 7 the value is 0.0279936 and the product becomes 0.2364. In the second part of the problem, probability x plus y less than or equal to 8 we have to calculate, which can be written as 1 minus probability x plus y greater than 8. So which can be written as 1 minus probability x plus y is equal to 9 plus probability x plus y is equal to 10 plus probability x plus y is equal to 11. Now we will calculate probability x plus y is equal to 9 as 11C9 0.4 raised to 9 and 0.6 raised to 2. So 11C9 the answer is 55. 0.4 raised to 9 the answer is 0.000262144 and 0.6 raised to 2 can be written as 0.36 and the product becomes 0.00519045. Then probability x plus y is equal to 10 is written as 11C10 0.4 raised to 10 and 0.6 raised to 1. 11C10 the value is 11. 0.4 raised to 10 the value is 0.000048576 into 0.6. So the probability becomes 0.0006920 and probability x plus y is equal to 11. 11C11 which is 1, 0.4 raised to 11 and 0.6 raised to 0. So 0.6 raised to 0 is 1, 11C11 is also 1 and 0.4 raised to 11 is nothing but 0.00004194. Therefore probability x plus y less than or equal to 8 can be considered as 1 minus 0.00519045 plus 0.0006920 plus 0.00004194. So total of these three numbers is 0.00592439,304 and the final answer is 0.994075. Now we will take some introduction of Poisson distribution. We experience number of situations where chance of occurrence of an event is a short time interval is very small. However, there are infinitely many opportunities to occur. The number of occurrences of such an event follows Poisson distribution. For example, number of customers arriving at a counter. Second, number of accidents on a highway. Third, number of printing mistakes in a book. Fourth, number of defective atoms found in a good lot of large size. Next, number of persons standing in the queue. Poisson distribution is applicable in statistical quality control, especially in constructing control charts and acceptance sampling plans. It is also applicable in the theory of reliability. It is found to be useful in theory of queues. So we will see the definition of Poisson distribution. A discrete random variable x is said to follow Poisson distribution with parameter lambda if its probability mass function is given by probability x is equal to e raised to minus lambda raised to x upon x factorial. The range of x is starting with 0, 1, 2, 3, dash dash dash, countably infinite range and equal to 0 otherwise. Notation is x follows p with Poisson distribution with parameter lambda, where lambda is the parameter, and for Poisson distribution mean is equal to variance is equal to lambda. Example based on Poisson distribution. The average number of misprints per page of a book is 1.5. Assuming the distribution of number of misprints to be Poisson, find first part of the problem, the probability that a particular book is free from misprints. Second part of the problem, the number of pages containing more than one misprint if the book contains 900 pages. Now let x denote number of misprints per page of a book. Now it is given that x follows Poisson distribution with parameter lambda is equal to 1.5. The probability mass function of Poisson distribution is given by probability x is equal to e raised to minus lambda raised to x upon x factorial. The range of x is starting with 0 and it is countably infinite. So 0, 1, 2, 3, dash 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 and equal to 0 otherwise. In the next step, we will replace the parameter. So probability x is equal to e raised to minus 1.5 raised to x upon x factorial. Now to find the probability that a book is free from misprints, that is nothing but probability x is equal to 0 is equal to e raised to minus 1.5 raised to 0 upon 0 factorial. Now e raised to minus 1.5, the value is 0.223031. Next, to find the number of pages containing more than one misprint if the book contains 900 pages. So it can be considered as probability x greater than 1, which is equal to 1 minus probability x less than or equal to 1. So which is nothing but 1 minus probability x is equal to 0 plus probability x is equal to 1. Probability x is equal to 0 already we have calculated. So we have to calculate probability x is equal to 1, which is equal to e raised to minus 1.5, 1.5 raised to 1 divided by 1 factorial. So which is nothing but 0.223130 into 1.5. So the answer becomes 0.33469524. And therefore probability x greater than 1 we will calculate as 1 minus 0.223130 plus 0.33469524. So the total of these two numbers is 0.5578254. So the answer becomes 0.442174. Therefore, number of pages containing more than one misprint can be written as n into probability x is equal to x. So value of n is given as 900. So 900 into 0.442174, which is nothing but 397.95. So approximately 398 pages.